Okay, so let's actually get into solving this, okay? Um, so the first thing that they want is angle D. As we mentioned in the previous video, we can see this arrowhead. Okay, I'm going to color it in for us again. So we can see that arrowhead. And we know that that arrowhead is theorem 2. Theorem 2 tells us angle at center, the one that's in the center. So it's going to be, let's get that back. It's going to be this one. It's going to be double that one. Okay, so let's write that down. So we're going to say angle D is equal to a half, right? The one at the circumference is half the one at the middle. So it's going to be half your 104 degrees. Okay, 104 degrees. And you need a reason over here. So I think I'm running out of space, but let's see what I can do. I'm going to say that angle at center equals 2 times twice the angle at your circumference. Okay, maybe we can't see that, but I'm writing circumference. Okay, I know I've written on top of those other words there. Angle at center is twice the angle at the circumference, and then obviously a half of 104 is 52. So we know angle D is 52 degrees, right? Okay. Next, they want angle C. Okay, so let's see, where is angle C3, right? C3. So they want, let's put it in some other color for us. Let's go with light blue. They want C3, which is this one. Okay, so we mentioned our bow tie theorem. So I'm going to color it in so we can see our bow tie. Right, okay, hopefully that is clear enough. We see the bow tie, and because of the bow tie, we would know that B and D are equal, right? And then we'd also know that A2 is equal to C3, bow tie theorem. Okay, I think I made that arc too big. C3, C3, okay, right, C3, I can't make that arc. Anyway, so we are going to say C3 is equal to angle A2. Right? Or we can go straight to say that that is equal to our 32 degrees. And then again, our reason. So when we use that bow tie theorem, um, we used to, okay, so maybe I shouldn't tell you what we used to write, but we used to write that point D and point B would subtend equal angles, because point D and point B both go to form those two, right? Okay, so that is what you see when we think about the bow tie theorem, but our reason is angles in the same segment. So angles in the same segment. Right, angles in the same segment is your reason for C3. Next one is A1. Okay, so let's look at this. Let's go put this in maybe red. Hopefully, we'll still be able to see. So C, A1, A1, A1. A1 is over there. Okay, so we're gonna color in this one over there. I think we did see this also in the previous video that I made. Okay, and that shape is an isosceles triangle. Why is it an isosceles triangle? Because two of our lengths are the same. Both of them are radii. Okay, so we'll say OA is equal to OC. How do we know this? This is radii. Okay, then we also know, uh, so okay, rather because of those radii, we know that A1, angle A1, is going to be the same as angle C1. The reason we know that is angles opposite equal sides. Angles opposite equal sides. Angles opposite equal sides. Right? That is because of that isosceles triangle, and we mentioned that our reason is angles opposite equal sides. So what will A1 be? Okay, so let's go look at our triangle quickly. Um, let's go look at that triangle that we have. So because A1 and C1 are equal to each other, we'll say 180 degrees minus, okay, let's write this down. We'll say that A1, okay, let's just write that a little bit nicer. is going to equal to 180 degrees minus the 104. Okay, but we're going to divide all of this with 2, and that's going to give us, or the reason for this rather, is the interior angles of our triangle. Okay, let's put that all of that into the calculator. So 180 minus our 104, divide that answer with 2, and it's going to be 38. So we know that A1 is going to be our 38, and these are degrees that we're working on. Let's go back to our picture. Okay, next they want C2. Okay, so C2 is this small angle over here. So how are we going to find C2? So we already know C3, we've proven that. We already know C1, we've proven that. And I think in our previous video also, okay, I know I'm making a reference to that video a lot. So if you haven't seen it, go check it out. But in that video, we made reference to, what color can we use now? This triangle that is created because of our diameter. Okay, and now if our diameter subtends an angle, we know that that angle would be a 90-degree angle. So the entire angle C is 90 degrees. All right, so let's say that. So we'll say angle C is equal to 90 degrees. How do we know angle C is 90 degrees? Well, that is angles in a semicircle. Right, angles in a semicircle. Right, and because the entire angle C, let's go back to our picture. Because our entire angle C is 90, we want C2, so we're going to say C3 and C1. We're going to subtract those two values from our 90 in order to get our C2. Okay, so let's just write that down. So we'll say C2 is going to equal to our 90 degrees minus, what was C1? Um, C1 and A1 are the same, so C1 is 38 degrees. And what is C3? C3 we said was 32 degrees. Right, so we're going to say 90 minus our 38 minus our 32. 90 minus our 38 minus our 32 in the calculator. And the calculator says this is going to be 20 degrees. All right, so that is the entire question. But again, in summary, go look for your different shapes inside your question, so you can try and identify which theorems fit. So go look for your bow tie, go look for your diameter, go look for your arrowhead, go look for all of those. Go, well, we don't have any tangents here, right? But if there was a tangent, go look for the tangent inside, and the triangle inside the circle. Go look for all of those things, and once you find one of those shapes, then it will be easy to identify how to move forward in the question. All right, good luck.